Okay. So, we'll talk next week about magnetic north versus true north, but for right now I want to define what a magnet, this isn't really what they look like, but it's what physicists define or how they differentiate between a permanent magnet and a temporary magnet. Permanent versus temporary. And if you're not a note taker, I don't require notes. Might not be a bad idea to at least have a scratch piece of paper out because I'm going to ask you to sort of interact here. And if you want to, I had some kids earlier today that just they don't want to be bothered with notes, so they ended up writing on their arm. You know, whatever makes you happy.
Wow. So big.
Okay. So, difference between a permanent and a temporary magnet. Since iron just has that one little rogue electron that breaks the rules and we end up with that double spin, it creates just enough electromagnetic field in a single iron atom to make it magnetic. It also then clusters together in little sort of clumps of atoms, and we call those magnetic domains. And a magnetic domain is a cluster of atoms that are themselves magnetic. In fact, early explorers would kind of knew this, not at the microscopic level, but they knew that you could turn like a needle that had enough iron in it into a permanent magnet by taking lodestone. So this is something you would dig up out of the ground, but this is a little heavy to turn into a compass, right? So if you had something very small and magnetized like a needle, you could float that needle on a leaf or on a small, like a light piece of cork and turn it into a compass. And it would align itself with the Earth's magnetic field. Everybody close your eyes. Everybody close your eyes. And I want you all to point north. Point north. Keep your eyes closed. Point north. Keep your eyes closed, Matt Van Winkle. Point north. Okay, oh, and we're moving. And they've got some fingers. Okay, keep pointing. Ah, close your eyes. Close your eyes. I'm recording all the fun directions that you're all pointing, I think. All right. Yeah. Now open your eyes, but don't move. And look around. What would you say a majority of the room, which way is the majority of the room pointing? Toward the board? Yeah, I would agree. Jesper pointed toward the... Yes, thank you, dear. Jesper pointed that way. So which way is north?
That way now.
Now that Jesper pointed that way, it must be that way? Yeah, it's the board. Here's the question. Which way is the lake?
West.
That away, yes. The lake is that way, so that's west.
I was like, I know the lake is that.
Yeah, yeah. It's interesting because without a large geographical reference point, it is really hard to know north, south, east, west. Do you guys most of the time know which direction you're heading, north, south, east, west?
No. Your car tells you.
Oh, your car tells you. You know what? I didn't realize I actually kind of have an internal compass. So I always have. This is strange, but even when I'm somewhere where I don't know where I'm going, I have a really good feel for north, south, east, west, like based on the sun or just. And I found out that was weird last summer when Annie and I were doing college visits, and I'm like, "What do you mean you don't know which way you're looking?" She was like, "Because looking at maps and walking around college campuses, not everybody has. I'm like a pigeon. I know which way north is." So, if you took this lodestone and rubbed it across a needle enough times, you could align these magnetic domains that are clusters of atoms that they themselves are magnetized. And what you would get, the way physicists like to draw because they love schematics, right, are little vectors inside a permanent magnet, all pointing in the same direction. So each of those little arrows represents a cluster of atoms. And if they're all working together, we have a permanent magnet. A temporary magnet would be these paper clips. These paper clips are, right now, magnetized. And their magnetic domains look like this. But what happens when I take them away from the lodestone? That's exactly right, Justin. We should get that on film. It's not really film, is it? This is what the paper clips look like most of the time. So some materials can be permanently magnetized, like my scissors. Probably half of this box of scissors, maybe more, are magnetized. Some things are only temporarily magnetizable. So once you take them out of a strong magnetic field, they just do this. Now you know, because you've probably played with magnets at some point in your life, or you have magnets at home on your fridge, you know that the magnetic field doesn't just exist inside the magnet, it extends beyond or outside the magnet. And Jody noticed that the lodestone kind of behaves like electric fields in that it tends to be strong at the pointy spots. And that is true for magnets as well. They have special names, these ends of the magnet where the magnetic field is strongest.
Oh.
Yes, they are called poles. Now, the direction of the magnetic field lines is completely arbitrary, just like it was for electric field lines. So, the first bald white guy to say magnetic fields point out of the north, and they end up pointing into the south.
Is that correct?
Who knows? That's just tradition. We're just back to that same thing again, right? It's not necessarily right or wrong. It's just that we have a standard for communication. Yes?
Doesn't the Earth magnetic pole switch every?
It certainly does, and we will talk more about that next week. Yes, sir, it does. So, this is where I want you to give this a try. Now, at the ends, where the poles are the strongest, that's where there's a lot of magnetic field. But I want you to take a guess at what the magnetic field lines look like above and below this bar magnet. Draw it. Draw it on your paper. If you are like some of the kids earlier today, feel free to draw it on your arm. Second hour, they were all drawing it on their arms. Yes. Thank you for being the keeper. It was just, you just had to keep it a secret. All right, so share with the person sitting next to you. What do you think the field lines look like? And I know that honor students don't like to do this because you might do it wrong, and then you would have to cross it out or erase it. No, seriously, right? I had kids that were like, I have it in my mind. I know what it looks like in my mind, but I don't want to put it on the paper because then it might be wrong. Let me check a couple of you. You are refusing to write it because it might not be right. That is lovely. Stop it.
How we think it acts like here and here.
What you said? You want to write it wrong?
I wrote it on
Oh, okay. You wrote it on Jim's little scrap of paper?
I'm brave enough to draw it.
Ow!
Very nice.
And Winkle?
It's on here. It's a mark. It's a line.
Are horrible people.
Why would you
I
come
like
here?
that one. Thank you, Mark. You never write anything. But at least he participated when I said to. That's true. Wesley gouged his arm.
Substitute teacher in there, we watched the same movie.
That was bad.
Watch it figure out the test.
I like this.
That's all right. That's all good ideas. You see this.
Did she tell you the story about teaching kids to work tempestuous?
You said Mr. McCombs was it, so check your
Talked
arms,
a
check
lot
your
about-
person.
He's gonna look at that. Watch me
I
this
told
tomorrow.
I forgot, right?
I'm gonna use this.
Oh,
Take off the
I was wondering, I was having like a little deja vu thing, like seeing you sitting here, I'm like, all right. Some of you had lines like this, which makes perfect sense. Out of the north, into the south. And just like electric field lines, the more dense the magnetic field lines are, the stronger the field. But what happens when you get like to the middle? Does it just keep going like this?
No.
No. Because then what happens when you're like right here?
They explode.
Right. So no, that doesn't happen. They explode. What happens is the magnetic field lines loop around kind of like they did with electric fields. Like that. Like that. Okay, keep going. But notice that in this spot right here, it's heading in the opposite direction of what's going on internally in the magnet. And that's a little freaky. That's a little bit weird.
It's just scary.
How about a horseshoe magnet?
I know what it's like. I like magnets.
So what do you just
What?
How'd my art? How was that? Is that really good? Thanks. I feel judged sometimes. Jody's such a good artist, and I'm all like, is it good enough?
That's a big deal.
All right, so here's a horseshoe magnet. I don't know if we're still videotaping because the screen is black. Movie recording. Oh, I think it says movie recording. I don't know.